Hi everyone, it's Math with AUB. Let's see some questions regarding the preparation of SAT, GMAT and GRE. Which of the following must be an integer? Which of the following must be an integer if x is a positive integer and 4 divided by x plus 5 divided by x plus 6 divided by x is an integer? Then which of the following these 5 options is always an integer? We have 4 over x plus 5 over x plus 6 over x is an integer, where x is a positive integer, means simply natural number. Denominators are homogeneous in that case. In these fractions, write x one time, simply no transition in the numerators, add them up. 4 plus 5 plus 6, we have 10, 10, 15 over x. Now this quantity is an integer. Let's explore the possible values of x that give 15 over x as an integer. 15 over x is integer. 15 has the factors 1 as well as 3 as well as 5 as well as 15. These are the possible factors of x. These are the possible values of x. These are the possible factors of 15. If we take x 1, either 3, either 5 or 15, they all 4 possibilities give 15 upon x is an integer. How? 15 over 1, it is an integer. 15 divided by 3, result is 5, it is also an integer. 15 divided by 5, it is also an integer. 15 divided by 15, it is also an integer. So these are the possible values of x. 1, 3, 5 and 15, because 15 over x is an integer. That is the restriction. We have to work within it. 15 over x. We simply write, we have simply written the factors of 15. 1, 3, 5 and 15. We have verified 15 over 1, it is an integer. 15 over 3, it is also an integer. 15 over 5, it is also an integer. 15 over 15, 1, it is also an integer. So this comply with our first demand, that is, it will give, this gives an integer, this gives an integer. Okay, now from the options, take A, whether it gives us integer or not. X over 5. If we take 1 over 15, it is not integer. 3 over 5, it is not integer. In these two cases, it will give an integer. So this doesn't qualify for x upon 5 to give an integer. If x is 3, 1 over 5, it is not an integer. If I write 3 here, 3 divided by 5, it is not integer. In these latter two cases, it is possible. But overall, x upon 5 is not an integer. So do away with this possibility. Eliminate option A. Option B, 5 over x. 5 divided by 1, it is an integer. Good. Oh, 5 divided by 3, it is not an integer. 15 divided by 3, it is not an integer. 5 upon 5, it is integer. 5 upon 15, it is also not an integer. So this possibility 50-50 works as an integer or not. Means 5 over x doesn't give overall integer. On these 4 possibilities. Eliminate option B as well. What about x? See option x over 30. If I write 1 over 30, it is not an integer. 3 over 30, it will give 1 upon 10, it is not an integer. 5 over 30, 1 upon 6. 15 over 30, it will go to 1 upon 2. So it gives nowhere an integer. Let me write 3. Let me write 15. It will not give an integer. What about 30 over x? Taking the D possibility, D 30 over x. Plug in 30 over 1. 30 over 1. Yes, it is an integer. 30 divided by 3. It is an integer. 30 divided by 5. That's equal to, it is an integer. 30 divided by 15 is 2. It's also an integer. It's also an integer. So D is our right option that give integers everywhere. That is 30 over x. 30 over x. One can check the possibility E, x over 120. It fails over here. 1 over 120 is not an integer. 3 over 120 is not an integer. 5 over 120 is not an integer. 15 divided by 120, it is not an integer. So our right option is D, that is 30 over x. It gives always an integer, because we have only 4 possibilities for the value of x, that is 1, 3, 5 and 15. Moving towards next question, we have that reads as, if x, y, z are positive integers, x, y, z are positive integers such that 0 is less than x, x is less than y, y is less than z. 0 is less than x, x is less than y, y is less than z. And x is an even, y is odd, and z is prime. Then which of the following is a possible value of the sum of x, y and z? We have restrictions. Rx, it is greater than 0 because it is positive. So does y as well as z. They are positive. Furthermore, x is even integer. X is even integer. Cool. And y is odd integer. They are all positive. And z is a prime. Z is a prime. And we have given the condition x is less than y, y is less than z, or one can write z is greater than y and y is greater than x and it is greater than 0. It's greater than 0. Now we have to sort out the possible value of the sum of x, y and z. Here maintain the condition. X is an integer, even integer, cool. Y on odd integer, and z is biggest of both, x as well as and is a prime, So we are sure and safe to conclude that it's an odd prime. Because 2 is the only prime, 2 and our z is greater than x as well as greater than y. So it is not 2. So z is not 2. If z is not 2 and it is a prime, so it must be odd. Now we are interested in the sum of x plus y plus z. X is even, y is odd, as well as z is odd. Now even, we are familiar, odd plus odd is even, even plus even is even, so we can safely eliminate choice B, choice C, choice D. Choice B, choice C, choice D has been eliminated because they are odd, and here the sum of x and y, z parallel to the given condition, according to the given condition, satisfying complying with these conditions, x plus y plus z is an even number. So there is a brawl or tug of war between 4 and 18. Let's decide which one is our option. 4 or 8. If I take x is equal to, that's even integer. If I take y 3 and I take z 5 and I take z 5, surely it's tantamount to 10. It is tantamount to 10. So we can easily eliminate choice A as well. So E is our right option in that case. taking particular value for this, or x might be 2, y 5, and our z is it might be 7 and 11. 7, 11. Okay, let it take it 5. Let me take it 5. Look at this. X is an even, y is odd, z is prime as well as odd. Prime as well as odd. Add them up, they add up to 18. So our E is the right option. 4 might be possible, 18 might be possible, but 4 doesn't satisfy our minimum condition. If I take minimum value of x2, y3 and z5 according to the given condition, it is more than 4, so it is safe to conclude that our E is the right option, as well as I have taken the values according to option E. X even, cool, y is odd, cool, z is prime, it's cool, and they add up to 18. Moving towards next question, it reads as, if the sum of 4 consecutive even integers is q, then the sum of next 4 consecutive even integers must be. We have given the sum of 4 consecutive even integers is q. It's very safe to assume that 4 consecutive even numbers, 4 consecutive even integers, 4 consecutive even integers. Am I right? On safe side, assume that they are x plus 2, x plus 4, x plus 6, x plus 8. I have taken simple one starting from 2, 4, 6, 8. These are the even integers to give you good idea to grapple with the situation with no effort. X plus 2, x plus 4, x plus 6, x plus 8. These are 4 integers. We have given that their sum is q. Sum them. Their sum is equal to q. Cool. Add them up. X plus 2, x plus 4, x plus 6 and x plus 8 is equal to q. X times plus x plus x plus x, 4x. 2 and 4, 6, 6, 6, 12, 12, 8. It will become 20 is equal to q. Now solve for x. Solve for x in order to shape our question to proceed further. It will become q minus 20 dividing by 4, q minus 20 divided by 4. That's my value of x. That's my value of x. That's my value of x. Now it is the value of x. If I replace here, then I will get the value of 4 consecutive even integers in terms of q. Or directly we are asked to find then the sum of the next 4 even integers. Next 4 x plus 2, x plus 4, x plus 6, x plus 8. Next 4 even integers. Next 4 even integers, they must be x plus 10, x plus 12, x plus 14 and x plus 16. X plus 16. We are interested in their sum. Add them up. X plus 10, x plus 12, x plus 14, x plus 16, x plus x plus x plus x. Same 4x, 10, 12, 22, 22 and 30. 22 and 30, 22 and 30. It will become 52. It will become 52. It will become 52. Or all options are in terms of q. Replace the value of x in terms of q. To get to the answer. 4 times x means q minus 20 divided by 4, no more, plus 52. Now we have q minus 20 plus 52. The answer is q plus 32. Q plus 32 is the sum of next 4 even integers, next 4 even integers, next 4 even integers. We have given the sum of 4 consecutive integers is q. We have simply managed x plus 2, assume x plus 4, x plus 4, x plus 6 and x plus 8 are the required even integers. Sum them up and I have written x in terms of q. If x is written in terms of q, then it's really very cool. We are asked to find the sum of the next 4 integers. The next 4 integers are the next 4 even integers. The next 4 even integers are x plus 10, x plus 12, x plus 14 and x plus 16. Add them up and replace the value of k and plug in the value of x, that is q minus 20 over 4. It will give us x plus 32. Moving towards next question, we have if p represents the product of the first 15 positive integers, then p is not a multiple of what? 99, 84, 72 or 65. We have given p represent the product of the first 15 positive integers, means p is equal to 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10 into 11, 12, 13, 14 and 15. 13, 14 and 15. If like a child, factorize them or factorize all the options. If their factors are present, it is not our option. At least find a factor that is not present in our options. We have 1, 2, 3, 4, 5, 6 up to 15. Factorize them taking first option, that is 99. I can write this as 3 square into 11. 3 square 9 as well as 11 both are present. So this is not the case. Taking option B, 84, factorize it. 84 table of 2, 4 times 2 times 2 again, 21 times 3, 7 times 7. Look at 2 square, 4 is present, 3 is merely present, 7 is also present, so it is not our option. Discard option B as well. What about 72? We are familiar. Let's factorize 8 into 9. 8 and 9 both are present here. 8 and 9 both are present. Leave it. What about 65? 5 into 13. Look at this. 13 is present, 5 is present. It is not our option. What about 57? Let's see and find out. It is going to be a right option. How? It's a simple fact. Just utilize 57. 57. Applying table of 3. 1 time 1 3 the 3, 2 carry, it will become 27. 3 7 the 3 9 the 27. 3 9 the 27 and 19 is the prime. So we have factors 13 and 9. Look at this. It is the product of 1 to 15 numbers. It is the product of 1 to 15. From 1 to 15. From 1 to 15. And 19 is not present here. 19 is not present here. So we can safely conclude that if P represents the product of first 15 positive integers, then P is not a multiple of 57. Then P is not a multiple of 57 because it is P is divisible by 99. 84, 72, 65, but it is not divisible by 57 owing to the presence of 19. Moving towards next question, we have